Welcome to this tutorial. Yeah, this is the part 2 of the tutorial introduction to fluid mechanics. So I was solving some questions that has to do with Newton force, Newton law of viscosity. So in this question, I said the plate has an area of 1 meter square. 1 meter square. Then it slides down an inclined plane. Now an inclined plane. When your weight is sliding down, your weight will be W sin theta. And remember, they said it is having angle of inclination of 45 degrees to the horizontal. So you have 45 degrees here. So after that, you are still going to know your weight when we reach the end of the question. So with a velocity of 0.5 meter per second, that means V is equal to 0.5 meter per second. What else again? We're given the thickness. Thickness of oil film between the plane and the plate is 1 millimeter. So your thickness is 1 millimeter, which should be equal to 1 times 10 raised to the power minus 3 because of the millimeter. Then what else again? Then after you should find the viscosity of the fluid. That is dynamic viscosity of the fluid. If the weight of the plate is 70.72 Newton, that means this weight is 70.72 sin theta. What's theta? Theta is 45. So let's calculate 70.72 sin 45. Yes, it's 50. Our weight is 50 Newton. So W is 50 Newton. So here now we have to calculate the viscosity. Let us write out the formula for shear stress first. So we know where we are going. Shear stress is equal to dynamic viscosity multiplied by du over dy. And when you are calculating force, this is the Newton's law of viscosity. It says that shear stress multiplied by area. Remember that shear stress is force over area. So we want to bring this formula inside here. Remember I told you this one can also be V and this one can also be T, depending on whatever is given to you in the question. Here we are given our V, our velocity, and we're also using our thickness. So let's bring it here. We have this multiplied by A.
Continue.
So this is our weight was given to us as 70.72, which we use here. So the force will be equals to this. That means force is equals to W sin theta. So that means your force is what? 50 Newton. So bring that force here. 50 is equals to, this is what I'm looking for. Multiplied by, what's our B? Our B is 0.5. Multiplied by T. Our T is 1 times 10 raised to the power minus 3. Then multiplied by our A is 1. So this one is not valid because if the times by 1 is still 1. Let us make use of the formula. It will be 50 multiplied by, you see the same thing, times 10 raised to the power 3. Then all over 0.5. So let's work that out now. Having 0.1. So you have gotten the 0.1, and remember the units for dynamic viscosity is Newton seconds per meter square. You can also convert it to poise because one poise is equals to 0.1 Newton per meter square. So this one is also equals to poise. So this is the answer for this. You have gotten the viscosity. Now let's go to the second one. Let's go to the second one. A flat plate weighing 0.5 kilonewton. The weight is 0.45 kilonewton. As a surface area, our area is what? 0.1 meter square. It slides down. It's sliding down again. So we have that inclined plane sliding down and making an inclined plane of 30 degrees to the horizontal again. So we have 30 degrees here. At a constant speed of 3 meters, that means your V is what? Your V is 3 meters per second. So if the inclined plane is lubricated with an oil of viscosity 0.1 Newton per meter square, That's a poise. So you have been given your dynamic viscosity to be 0.1 newton seconds per meter square. They now ask you to find the thickness. So this time we are looking for T. Remember the formula. Let me write it out. Is equals to dynamic viscosity multiplied by V over T, or V over T is the velocity. So we are looking for this. We are given weight, but you know these parameters are not complete, so we have to use Newton's law of viscosity. This says that force is equals to tau multiplied by A as shear stress. So we bring this here. We have force is equals to dynamic viscosity multiplied by V over T, then A. From here we can make T our subject of the formula. I'm bringing it here first. So you have TF is equals to dynamic viscosity multiplied by A. So this F will come here since we need this T. So your T will be multiplied by B multiplied by E over F. But we need to get our F. Since our weight is this, and we already know that our weight, our force will be equals to W sin theta. Why? Because it slides down in an inclined plane. As when we are to determine the vertical and horizontal components, we know that horizontal component will be what? F, the fx will be what? F cos theta for the fx and F sin theta for the vertical. But now we are dealing with the inclined plane. Is the object is what? Sliding downwards. So this is what we use for that. So you have B is equals to, what's our W? 0.45 sin, what's our degree? 30. Let us put that down. 0.45. We have 0.22. This is in kilonewton. This is in kilonewton because remember this kilonewton here, so you have to convert it back to newton, and you multiply that by, you know, kilo is 1000. Multiply it by 1000 newton. Multiply it by 1000. So your force will be 225 newton. So you now come here, insert all your parameter and get your thickness. So thickness is equals to our dynamic viscosity is 0.1 multiplied by our V is 3, our A is what? 0.1, and our F is 225. Let's see what we got here. 0.1. So we have 1.33 times 10 raised to the power minus 4 should be in meter. Yes. Answer. So we've gotten an answer to 1.33 times 10 raised to the power minus 4 meter. Can convert it to millimeter. How? Multiply it by times 10 raised to the power 3. Remember, here when we wanted to convert this to meter back, we use times 10 raised to the power minus 3. But now we are converting it back to millimeter, so we are using times 10 raised to the power 3. If you do that, it's going to give you 0.133 millimeter. So this is the end for this part. I'm going to be doing more examples on pressure, more viscosity.